This is a short demonstration video for our project submission at Innovations in Software Engineering Conference 2020. Our project is on ER diagram generation tool. This tool accepts user input specifications in natural language and generates live ER diagram from them. Some of the salient features of our tool are: it identifies the sentence structure using some Hornby patterns. Hornby identified the types of sentences in English language and classified them based on some sentence structures, and developed a set of sentence structure rules that we have used here to identify our sentence structures. Next, we find the entities, attributes, and their relationship using the sentence structure rules identified in the previous step and the parts of speech tags. Next, we generate our ER diagram. Tools used in our project are Python. We have used Python language here because it provides developers with an extensive collection of NLP tools and libraries. We have used NLTK library in Python, which is Natural Language Toolkit, and is a suite of libraries and programs for symbolic and statistical natural language processing. It supports tasks like classification, tokenization, stemming, tagging, and so on. Stanford Parser is the core component of our project. It analyzes the grammatical structure and gives us the relationship between the words in the form of type dependencies. GraphViz is an open source graph visualization software used for drawing graphs, specified in .language scripts.
Now, let us look at the working of our ER diagram generation tool. For this, we have divided our process into certain steps. In the first step, the user sends the input to the tool in the form of some sentences or paragraphs in natural language. These sentences or paragraphs in the next step are tokenized with the help of NLTK tokenizer. These tokenized sentences then are passed to the next step, in which the Stanford dependency parser and POS tagger further tokenize these sentences into words and finds their type dependencies and POS tags. In the next step, the identification of sentence structures of each sentence from their type dependency and POS tags takes place through the help of some sentence structure rules. These sentence structure and POS tags then in the next step give rise to the identification of entities, attributes, and relation between these entities through some transformation rules. In the final step, the generation and visualization of ER diagram takes place by our GraphViz API, which gives rise to our final output, that is the ER model.
Next, we move towards the implementation of our tool. The tool is designed such that it asks the user to enter the user specification. Now I am going to enter the user specification. Let's say the system validates the password entered by the user. The tool initiates the Stanford parser, tokenizes the sentence, parses to find the type dependencies between the words. Next, the sentence structure is determined, transformation rules are applied, and the entities and the attributes, if present, are found out. Next, the relationships are also found, and finally, the graph API is applied to get the ER diagram. In the intermediate output, we also see that we get two lists. The first one contains the entities and the second one contains the relationship between them. In the terminal output window, we have received two lists. The first one contains system and password as the entities and validates in the second list as the relationship between the entities. Since there were no attributes were identified. The output received in the form of a PDF file. However, we don't have to worry to find the file location of the PDF file. The PDF file is automatically produced in the default PDF browser. For example, here we have the Chrome as a default. The ER diagram is generated for the user specification input. The two entities and the relationship between them is finally received successfully. This is a very basic implementation of our tool. However, we have also used some complex test cases. For example, these are some of the test cases. Thank you very much.